So hello everyone. We are talking about DVMS, and we're talking about DVMS from like it's like third time that I'm talking about DVMS in this YouTube channel, and I'm going to tell you the topics that we have learned till now. So the topics are the topics are file system and DVMS. I'm going to explain this within like it's 216. I'll explain it till it's not 216 actually, it's 136. So it's 216. No, let's consider it's 216, and I'm gonna explain it till 220. So what is file system? Let's talk about file system and DVMS. So file system is like let me explain with example. System. I didn't call this as file system. Okay, whatever. So file system is like before earlier in the office, file system was like people used to keep the files somewhere in a centralized place, and it was like only one person would able to access that file, and the rest should have to wait. It's like when you talk about concurrency, file system was like not multiple people can access data at the same time. So it was like the multiple people were not able to access the data at the same time. But when it comes to DBMS, multiple people can access the data in a single time concurrently, and all the things are like um, talking about security. Security was like everyone would everyone, if they have access to the the place, they would they could access the file. Okay, it was very easy to it was literally too easy to access the file, like, and there was no role like admin can access this thing, you know manager could access this thing, okay, operator could access that thing. So it was not like this, everyone were able to, like, everyone were accessing the file, and it's like, but talking about DBMS, it's not like that. Let's talk about redundancy. Redundancy was like if there was like multiple data in a file, then it was way too difficult to find the you know same data, the repeated data. But talking about DBMS, we can easily track, and the thing is like uh, you can't store multiple data in DBMS using DBMS. If you are using DBMS, you can, but in file system, you can. Okay, you can, because it's too hard to um, get the data. It consumes a lot of time. That's about file system. Let's talk about two-tier architecture and three-tier architecture. So let me give this with some kind of examples to you. So two-tier architecture is like there where, like, let's consider this as client. Okay, so if this is client and this is database, so a two-tier architecture was is like client can directly access the data from the database, okay, directly. And it was like if it was like in two-tier architecture, client can directly access the database. And the problem with this is the problems are only few user can use this thing, okay, and scalability and security is a problem. Okay, it's a very big problem. And talking about maintenance is difficult to maintain. Okay, it, that's all about two-tier architecture. Okay, that's all about two-tier architecture. So when you talk about three-tier architecture, we have, you know, client. We also have something that is called, let me bring the full screen. We also have something called application server. Let's give it an AS, application server. And there is something called database. Okay, there is something called database, DB. So this is called three-tier architecture. There is something called client, application server, and one more thing that is called database. This is with three-tier architecture: client, application server, and database. If you talk about this, if you like, curious about what is application server, the application server is like, it's a program that is written, like we have said, a kind of program, okay, that will take the request and make the query and give the query. Okay, it's like give the query to the database. That's And what it does is it sends the response to the client. It gets the data and it sends a response to the client. This is called three-tier architecture. Like it's like application server. Talking about application server, it makes a logic what to send, what to display in the client, like what to say, what response to send, what to calculate. All the calculation and all these things are done by application server, and it only sends the required query to the database, and the database will give the data to the application server. And this is how three-tier architecture works. Just wait a second, okay. That's all about three-tier architecture. Talking about scalability, it is very, you know, it handles a lot of user, and the security is, I don't know, but like security is like, the client can't, as the client cannot directly access the database and don't really know where the data exists. So it's like more it's like, application server makes a kind of layer, okay, of security. And that's all about security. Maintenance is like you have to maintain a lot, as we have two server over here, like application server and a database. So it's like, you have to maintain a lot more in comparison to uh, two-tier architecture. So the next topic is SIEM. Okay, what is SIEM? SIEM. What do you think? What is SIEM? SIEM is a logical representation of a data. It's a logical representation in a data. Okay, and we know that data is it's represented in a table. It's a logical representation. SIEM is a logical representation of a data. And talking about SIEM, we have a course, and we can say that if this is a course table, okay, what do we have in course table? Or let's say that it's a movie table. What do we have? First thing, we have a movie ID. We have movie ID. Then movie ID. We have name. Okay, we do have name, and we do have something called duration. This is what you call 3SIEM architecture. 3SIEM architecture is like, it's like logically represented data. It's a logical representation. That's what I call SIEM. And this is how, this is the example of SIEM. Okay, this is example of movie table, movie ID, movie name, and movie duration. That's it. And to implement this thing, what do we use? We use something called SQL. This is just a logical representation. Logical representation is like, you know the table can look like this. Okay, we know that table looks like this, and we have written this in some kind of, we write this in some kind of like paper, or we write in some kind of other software, like, where we just represent it, we just create a figure of it. Okay, in that is same. But to implement this same, we're gonna use something that is called SQL. Okay, we use SQL to create. We have created this table in a paper, but to implement this, we need to use something like SQL. Okay, okay, so that's it. And let's talk about now 3-sim architecture. So 3-sim architecture is like, um, you know, 3-sim architecture is like, we have three different levels. Okay, it's like, there are literally three levels between user and database. As you can see that we have three levels between user and database. That is what is called 3-sim architecture. 3-sim architecture is like, we have three levels between user and database. That's why it's what I call 3-sim architecture. And talking about 3-sim architecture, we're talking about 3-sim architecture. We have different kind of level. The first level is, uh, external sim. External sim is like, front end. Let me show you, okay, how it works. Like, so 3-sim architecture is like, we have user. Okay, we have user, we have external sim, we have conceptual, and we have physical physical sim, and we have database base. Okay, so these are the things that we have. We have a user, we have external sim, we have conceptual sim, we have physical sim, and we have database sticks. So 3-sim architecture means like, 3-sim architecture is like, we have three levels. Okay, three levels between user and database sticks. In external level, in external sim, we who works is like, in external sim, front end developer works in this external sim. They develop the website, they develop the, not the entire website, the front end. Talking about concepts of sim, here we develop something that is called, we design a database. Okay, in the concepts of sim. Talking about physical sim, what we do here is, we, like, database admin, what I call DBA, database administrator, work in this place. And what he does, it he handles these hard disks. Okay, so that is all about 3-sim architecture. 3-sim architecture is like, there are three levels in between user and database disks: external, conceptual, and physical sim. Okay, so that's all about what we have learned till now. I'm going to explain about what we will learn today. So we will learn about something called database data independence. We'll talk about integrity constant. We'll also talk about, candidate key and primary key. So these are the things that we'll talk today. So let's first start with data independence. So data independence is like the word. What this suggests is, whatever we make changes in any of this level will not affect another level. Okay, if we make some changes to this level, physical same. We know that what we do here is, we write, we create or we handle the text in this physically, in physical devices. Okay, work as a physical. Conceptual is like the names of this. Conceptual is like, we design a database. And view level is like, we we create something called front end, something like that. Let me talk about something else. Like let me talk about what we will discuss in this session is, you know um, so talking about this database, you know, so let's say that I have a database that is DB1, okay, and I'm gonna send this data to DB2, okay. I have DB1 and I'm gonna take this data from DB1 to DB2, okay. So will it affect my conceptual sim, the design that I have created? Will it affect that? No, it will not affect. It will not affect, okay. So let me talk about this view level. Does it affect the view? Does it affect the way it needs to be shown? It will change the front end. Does changing in text change in front end? No, it will not. Okay, so it is independent. Okay, so let's talk about conceptual sim. Conceptual sim, talking about conceptual sim, the database designers or engineers, whoever work in this thing, the database designer or engineer keeps on changing, keeps changing the table. So database designer keeps on changing your table, but does it affect the view level? It will not. It will not affect the view level. The view level will be affected only if the view is changed. Okay, the view level is affected only if the front end engineer works in this or changes make some changes in his view level. Only in that case, the view level is affected. But in other case, the view level will not be affected by doing any kind of changes in physical scene, in conceptual scene, or in views level. Nothing will change, nothing, okay? So it is all independent. So that's all about data independence. The next topic is integrity constant. So integrity constant is like, integrity constant is a kind of like a rule, okay. It's a kind of rule, and using that rule we create a database. Integrity constant, using the integrity constant rule we create a database, and that's all about integrity constant. We use this rule to create database, okay, so that the data is not interrupted, or the data will not uh, you know like, in case in future we won't get any kind of problem related to database. If we can get a lot of problem, like, the problems, like, that's the problem, okay. Like, I mean, I'm going to talk about the problem. If we don't follow the integrated problem, what are the problems that we follow, that we get, okay. And so this is what we call integrity constant. So we know that this is integrity constant, okay. So this is integrity constant types, and this is domain constant, and this domain. So integrity constant is a rule that we use to create a database. We know that. And talking about this type of integrity constant, we have domain constant. Domain constant. So what is domain constant? So domain constant is like, let me explain you what domain constant is. So let's consider that we have a table of student, okay, table of student, and we have like a student name, roll number, and age, okay, or let's say phone number. So this is a database sim, and can you imagine that, like, can the student set the roll number as -2? No, absolutely no. The student can't set this roll number as negative. Can this, if we have the phone number, like we have 10 numbers in a phone number, we know that. Can the user set the phone number, like, can the user set 10, 11, 20 digit phone number? Can the user set the phone number digit as 100? No, user cannot. And to you know, to fix this, we use a different constant, like we're gonna use something called check is, you know uh, not less than zero. That is check is should be greater than zero, or then the phone number should be equal to zero, equal to 10. Okay, you cannot do that. You cannot say the phone number is greater than or less than 10. So these are the conditions that we use in domain constant. And if we follow this, we can definitely create a better database, isn't it? We can definitely create a better database. Let's talk about entity integrity constant. Entity integrity constant is like, there must be one primary key. Okay, then there must be one primary key in a table. Okay, in a table there must be one primary key, and that primary key must be unique, and it should not be null. The primary key, it should be, there must be one primary key in a table, and that primary key should not be, you know uh, it should be unique, and it should not be null. That's all about entity integrity constant. And when you talk about referential integrity constant, referencing something. Okay, referencing. Okay, referencing table, another reference table, referencing table, we know about these things. So a referential integrity constant is like, there would be definitely one primary key. Talk, like in this case we'll talk about foreign key. Okay, and there will be something called parent table, and there will be something that is called child table. Okay, and this parent table and child table is bonded by something that is called foreign key. So whatever that comes in parent table should come in child table too. Okay, it is something called inheritance that we use in uh, Java or something like those language. If there is a class name student, okay, if there is a class name student, and if there is a class name, you know course, or let's say like student fee, then we can definitely use this student student variables or methods or student data in this class. Okay, sorry guys. So that's what I call as a referential integrated constant. So whatever that comes in parent table should come in child table too. There is something called key constant. Key constant is like, there must be one unique column in a table. There must be one unique column in a table. That's what I call key constant. Okay. Now we will talk about candidate key and primary key. So candidate key and primary key is like, unique attributes. Okay, unique attribute set of unique attribute. Okay, that is what I call super key. Super key, super key. All the unique attributes, that's called super key. And you know from the super key we will choose one candidate key. We will choose one candidate key. What we will choose? We will choose one candidate key. From this super key, from whole the super key, we will choose one. There will be only one candidate key, and the rest would be named as alternate key. Okay, we will name the rest of the key as alternate key. There will be one candidate key, and a rest will be alternate key. That's the, and it must be unique. It must also be unique. But I'm still confused in super key and I'm still confused in the super key and alternate key. I'm gonna talk about this in next lecture if I get time. So that's all about the video. Thanks for watching. And the next video is going to be related with something called ADO.NET. And thank you everyone. Thank you whoever is in the stream. Thanks you.